Okay, welcome to this lesson on compound measures. Lesson 2 is on density. Now, density just means how heavy an object is in relation to the space it takes up, which is its volume. Think about, say, a 1 litre bottle of water. All right, if you filled the bottle full of water and then, say, dropped it on your head, it would hurt. All right, if you emptied the bottle and blew into the bottle to fill it full of air, if that dropped on your head, that would hurt much less because, obviously the bottle would be much lighter with air in it than water in it. That's because 1 litre of water is much heavier than 1 litre of air. All right, water is much denser than air. It's much heavier for the space it takes up. And the formula for density is here. Density is mass divided by volume. Remember, the mass of something is how heavy it is, and the volume is the space it takes up. And it looks a lot like speed equals distance divided by time, and it behaves very similarly. So let's do an example. So pause the video, write this down, and then come back when you're ready to see the answer. Welcome back. So a block of gold is a cuboid of length 10, width 4, and height 7 centimeters. The block has a mass of 5,400 grams. Find its density. Well, I'm going to draw a picture to help my brain here. So I'm going to draw a cuboid. Okay, like this. Remember, it's a 3D rectangle, like a cereal box, for example. It's got length 10 centimeters, width 4 centimeters, and height 7 centimeters. And the mass is 5,400 grams. Now, I know that density equals mass over volume. Now, I know the volume of this shape. It's 5,000. Sorry, I know the mass of the shape. Sorry, it's 5,400 grams. It's right here, you see. But I don't know the volume yet. But we should know, shouldn't we, from previous years or lessons? Remember, a cuboid's volume is just length times width times height. So for this cuboid, is 10 centimeters. The width is 4 centimeters. And the height is 7 centimeters. And if you work this out, then I think you get 280 centimeter cubes. You can use calculators today, okay, for this work, because the numbers are going to get quite messy. All right, so the volume is 280 centimeter cubes. If you do on the calculator, 5,400 divided by 280, all right, then you get 19.29, 2 decimal places. Now the units, remember, like with the speed, it's going to be grams on top of the fraction over cm cubed. See, because grams is on top, cm cubed is on the bottom. This is called 19.29 grams per centimeter cubed. All right, that's example 1 done. Example 2, pause the video, come back when you're ready. So, osmium is the densest element on Earth. The bar shown below is a prism, and it's made of osmium. I can see that, yeah, it's a prism. It's got a mass of 2,824 grams. Okay, so the mass of this prism is 2,824 grams. And I want the density. So again, I'm going to go shorthand now, okay? I'm going to use D for density, M for mass, and V for volume. I know the mass is 2,824 grams. But again, I don't know the volume. But remember, in previous lessons, we've done triangular prisms, haven't we, the volume? Remember, it's all about the cross-section. So I'll put a little separator here, okay? Remember, now the volume of a prism is the area of the cross-section, remember, times the length. Now this cross-section here is a triangle. All right, so I have to go up here. Sorry, I ran out of space. I didn't plan this out the best, right? So the cross-section is a triangle. Remember, a triangle's area is base 10 times the height divided by 2. Okay, and if you work that out, okay, then you're going to get 32.5 cm squares. That's the cross section. All right, so now the volume is going to be the cross section times the length, which is 4. Okay, and 32.5 times 4 should be 130. It is 130 cm cubes. So this prism's got a volume of 130 cm cubes. So that's going to go on the bottom of the fraction. And now I can work it out. Okay, so 2824 divided by 130 gives me an answer to 2 decimal places of 21.72. Again, it's going to be grams per centimeter cubes to 2 dp. Just checking one thing. Yeah, it's heavy. It's got more density than the gold. So that's the answer there, okay? 21.72 grams per cm cubed. So those are the examples done. Density is mass over volume. For the main task, it's on the next slide. It's here. Pause the video, have a go. Before you do start, though, I'll just remind you that the question 2 is a cube, and question 6 is also a cube. Bear that in mind. Have a go. And I want all the answers in grams per cm cubed. So be careful with question 6, exclamation mark. Okay, come back when you're ready for the answers. Okay, welcome back. Here's the answers. I've done them all to 2 decimal places. Remember, for the cubes, all the sides were the same. So these are all 12 here. So for this volume, you had to do 12 times 12 times 12. And for this volume, you had to do 9.2 times 9.2 times 9.2. And this was in kilograms. So you had to make it into grams first by multiplying by 1,000 to get 5,000 grams. So make sure that's marked, and then we'll do the checking question together. Here's the checking question. So pause the video, write it down, have a go, and come back when you're ready for the answer. Okay, it says work out the density of the blank below. Well, remember, this is a cylinder. Remember, it's like a can of beans. It's got a mass of 20 tons. Give your answer in kilograms per meter cubed. Right. So I think I'll go on to a blank slide here. All right. It's got a mass of 20 tons. All right. And so density is mass divided by volume. See, the question said I want the answer this time in kilograms per meter cubed. All right. So I'm going to need kilograms on top and meter cubes on the bottom for this one. And I spot that this 20 tons is not in kilograms, but it soon will be, because remember that 1 ton is 1,000 kilograms. So if I'm going this way, I am multiplying by 1,000. So 20 tons is 20 times 1,000. That's 20,000 kilograms. So this is going to be 20,000 kilograms on top. All right. Now, as for the volume, this will take a bit of work. Okay, so I think I'll put it down here. This will take a bit of work. Well, we've done it in the past, remember? A cylinder is a prism. All right. So the volume is still the area of the cross section times the length. All right. And again, on this shape, if I do it in yellow, remember the cross section is the flat bit there. All right. Which for a cylinder, this is a circle. All right. So this here is a circle. That's the cross section. So remember now, let's do the cross section first then. So the cross section, remember, a circle's area is pi times radius squared. And for this circle, the radius is not 20. The radius is halfway across. It's 10 meters. So it's pi times 10 squared. Okay. Now, I think I will use a value for pi. Okay. No, actually, I'll use my calculator's pi button. All right. if you haven't got a scientific calculator, remember you could just use 3.14 for pi. But on my calculator, okay, I get 314.16 cm squares to 2dp. If you used pi as 3.14, then you would have got exactly 314 cm squares, okay? Either one's fine. So now my volume is the area of the cross section, okay? Oh, again, see, I made a little mistake here, haven't I? Before I forget, sorry, look. It's not cm squares, is it, for this one? It is meter squares. See, because my question values are all in meters. Sorry, so that's meters squared there. So the volume is 314.16 meters squares times the height or the length. See, this is the length of the prism here. So times 50 meters. And so 314.16 times 50 is a rather large number. 15,708 meters cubed. So that's the volume. Done. So now I can put that in here, can't I? 15,708. And I can work it out on the calculator, all right? So 20,000 divided by 15708. That gives me a density of 1.27. And that is 2dp. And again, this time, it's going to be in kilograms per meter cubed. But I'm pretty sure that's what the question wanted, didn't it? Yeah, it did 1 kilogram per meter cubed. So with that, we're done. So thanks for listening and watching. Stay safe. See you soon.